Which of the following alkenes would yield an alkyne upon addition of Br2, followed by reaction with more than 2 molar equivalents of our very strong base, right? Really, the exact base here doesn't matter. Just the fact that that's that very, very strong base that can remove those H pluses next to those Brs, right? Okay, and so really we're looking for a few things here, okay? Number one, we have to actually have enough H's that we could remove 2 degrees of saturation, okay? We wouldn't be able to do this if we have a carbon that's going to make it so we can't make a triple bond, right? So we look at here, and the first thing I want to point out is how many bonds does this carbon have going to it? Well, it has 1, 2, 3, 4, doesn't it? Can it even add another pi bond? No, it can't add another pi bond, can it? And so automatically that tells us that's not possible, right? We look here, 1, 2, 3, 4. Well, again, that can't even add another pi bond there, can we? And so C becomes a non-go. It's just a non-starter. We can't do it at all. It's not possible. D, 1, 2, 3, 4 again, isn't it? Well, shit, we can't even add another pi bond there, can we? So again, it automatically becomes a non-starter. But we actually managed to eliminate everything but one, didn't we? The only one left is B, 1, 2, 3. 1, 2, 3. So that could add another pi bond that has a set of hydrogens on there we could strip off and make an elimination reaction, couldn't we? Okay. And how we're going to do that is, do you remember the alkynes we talked about just a little while ago? We can establish an alkyne by doing 2 elimination reactions. And we do that by having an H and Br on both of the carbons. So we remove an HBr across that, makes a double bond. Remove a second H and Br across that, remains a triple bond, right? That's how we're doing this. So we add a Br across there. That'll give a Br here, an H here, and H here. So automatically, to make a triple bond, we're going to have an H that's available on each of those carbons, aren't we? And that's what I'm actually talking about. And I pointed it out in the other direction, that if you have 3 carbons already bonded to that, you know, if you have 3 carbons and a pi bond already there, you just can't make another bond, can you? It doesn't have space for it. But you can also look at it the other direction. You need the hydrogen to do the reaction, don't you? So you need a hydrogen on each of these, or you can't even begin to do it. You won't even be able to do the reactions. Okay? An interesting side note is these right here could never even do the next step of this reaction, step 2, at all, because they don't even have hydrogens on these carbons. So you wouldn't even be able to make the double bond from that again. You'd actually be stuck on a halo alkane, and this reaction pathway would not work right. Okay? Is that making sense now? Okay. Did you have any more questions on this?